All right, guys, we are going to work on a problem that is going to be on your quiz tomorrow, or one that is the same structure as the one that's going to be on your quiz tomorrow. So this is testing for proportion, hypothesis testing. So our situation is that we're going to assume that Cristiano Ronaldo, who's a famous soccer player, if you didn't know, has scored on 19.6 of his shots over his career. He's getting older, though, so a statistician wants to see if that conversion rate has gone down this particular season. In our SRS of 62 shots, he has made 11. We want to test at a alpha equals 0.05 significance level. So these problems are broken down in 4 parts for you guys, like they have been over the last few chapters. We're going to state, plan, do, and then conclude. To start off, we need to state our hypotheses. And our hypotheses always start off with a null hypothesis, which is H naught, and an alternative hypothesis, which is HA. So we have H naught, HA, and we want to say that H naught is the condition or the environment that we're going to assume has carried over, that we have no reason to think that it has changed. So Cristiano Ronaldo scored on approximately 19.6% of his shots over the course of his career. We might not necessarily have any reason to assume that he's going to do any better or worse this year, so our initial assumption is going to be that he is going to shoot or score on 19.6% of those shots still. We don't think anything has changed, so we're going to use P, just regular P. Our population proportion is equal to 0.196. P equals 0.196. And then we want to look at our alternative hypothesis, which comes from our statistician. The statistician wants to see if he's gotten worse, if his conversion rate has gone down. So we're going to say that P is less than 0.196. So you'll always have equals on the top, and then either greater than or less than on the bottom for these hypothesis statements. And you should also notice that this number and that number will always be the same. 0.196 will be in both hypothesis statements because you're comparing them, and that actually this 0.196 or whatever numbers on the right hand side here is actually what our P naught is equal to. So P naught equals 0.196. It's our null proportion, or the proportion that we're going to assume is true at the start of the problem. Okay, so now we're done with the state section, so we have to plan. We have to check our conditions. So we have 2 conditions that we've been using. Our 10% condition, which says that our population, or our sample size, so our sample size, which is n equals 62, has to be less than 10% of the population size. So our population for this is actually Cristiano Ronaldo could theoretically take an infinite number of shots if he would like. So our big N, our population size, is infinity. Little n is clearly less than 10% of our population size, so we know that this is okay. If this was a finite number, you would have to compare them mathematically, but in this case we know that 62% is definitely less than 10% of infinity, and actually any finite number is less than 10% of infinity, if that interests you, which it probably doesn't. Our next condition is the large counts condition, LCC. This says that NP naught, which is equal to, in this case, 62 times our 0.196, n times P naught is equal to 12.152, that this has to be greater than or equal to 10. It is, so that's okay. And then the other part of that condition is that n times 1 minus P naught also has to be greater than 10. If you look at this, it's going to be 49.848, I think, something like that. I'm not sure. But anyway, it's 49, which is already greater than or equal to 10. So that's met. So both of our conditions have been met here, so we can proceed with our problem. Now we're halfway done. We're going to do the do stage, which is probably the hardest part of hypothesis testing. besides maybe stating our hypotheses correctly. So we need to find the test statistic first. So our test statistic is represented by z, and the formula for that will be given to you, but here it is now. If you have it down, that'll make your life even easier. It's p hat minus p naught all over the square root of p naught times 1 minus p naught over n. So we've already identified what p naught is. We've identified what n is. We need to identify what p hat actually is equal to. P hat is our sample proportion. I'm going to write it up here. So p hat is the proportion of shots that he's made out of the sample size. So he's made 11. We took a sample of 62. So our p hat is actually equal to 0.177. So now that we have all three of those variables, we are able to plug everything in and calculate what our test statistic actually is. So we have 0.177 minus 0.196 over the square root of 0.196 over 1 minus 0.196, and all that is over 62. You can simplify the top and the bottom. Don't mess up on a calculator error, hopefully. And we get negative 0.019 here. And from some previous math that I did, we get 0.05 here approximately, which simplifies to negative 0.38. So we found our z. This is a z. Don't forget that. So now what we have to do is find the p-value, and the p-value represents the probability that we get something as or more extreme than this. So we want to draw our standard normal curve so that we can double check our work. So we know that the center of a standard normal curve is 0, which means that negative 0.38 is going to fall here. We are looking to see if he's gotten worse. So we're trying to see the probability of him getting something as bad or worse than negative 0.38, which is his standardized proportion. So we're looking for really this area right here. This represents our p-value. To find that area, we're going to do what we've been doing for a while now in our classes, either using our table or our calculators, using normal CDF to calculate that area using the values. I'm going to use my calculator because I think it's easier. Remember that if you use your table, you might have to do 1 minus whatever area you find to make sure that you are getting the right area. But if you plug it into your calculator, it'll ask you for a lower bound and an upper bound of this area. The lower bound technically goes on forever that way, so you just need to pick a large negative number. Negative 100 is fine, even negative 10 would be fine. And then you need to pick an upper bound. The upper bound of this region is just the number that we bounded it with on the bottom here, negative 0.38. You would put that into your calculator without changing the mean or standard deviation, which are to be 0 and 1 respectively, because it's standardized, and we come out with a p-value equal to 0.352 after all that. So you found your test statistic, which allows you to find your p-value. We interpret this p-value as saying that there's a 35.2% chance that we find something as or more extreme than negative 0.38, given that our null hypothesis is true. That's how you would interpret it on the test. And now we have to actually make a decision about this information. So to do that, we need to compare our p-value. So I'm just going to rewrite it. Our p-value, which again is 0.352, we need to compare that to our significance level. So 0.05 is our significance level, represented by alpha. You'll notice here that 0.352 is definitely bigger than 0.05. So our p-value is bigger than our significance level, which means, so I'm going to say since our p-value is greater than our significance level, this is in your notes and the decision-making part, we are going to fail to reject. We are going to fail to reject the null hypothesis. We will fail to reject the null hypothesis. Because basically we don't have enough evidence. Basically what this is saying is that there's a 35% chance we could have gotten something that bad, 35% chance is actually still pretty high. It happens 1 in every 3 times. So we would expect this to happen anyway, every 3 times. So we're not that convinced that Cristiano Ronaldo is actually getting worse. So we're going to fail to reject the null hypothesis. A nice thing you could add in there now is that this means that this data is not statistically significant. So this is a problem that basically just mirrors what you'll see tomorrow and for the rest of the chapter, really. If you can do this, or if you understand this, it'll set you up to do well on both the quiz and the test, because when we test for means, it follows the same exact structure, except with just slightly different formulas. Very similar to how confidence intervals were the same between means and proportions for the most part. Anyway, if you need help or questions or whatever, shoot me a message on Remind. Otherwise, I'm going to go out and enjoy the sun. I encourage you to do that, or I hope that you did earlier before you watch this video, and just enjoy some of the sunshine. Other than that, please study for the quiz tomorrow, and I hope that you have a great night. See you in class.